So in this lecture we are going to talk about Lambda handlers and what are the different kind of handlers available in Lambda. So when talking about Node.js, and if you remember our first Lambda function, hello world, inside our handler.js file we had exported a handler called hello world, which was mapped to your serverless YAML files hello world function. So when you configure a function, the value of the handler setting is the file name and the name of the exported handler method separated by a dot. So in this case the file is handler, and then we have our hello world function exported. Our handler takes three arguments: event, context and callback, and it processes the events which are sent to it by the runtime. Now when runtime sends these arguments under events, it sends the information from the invoker. So in case of API gateway as our invoker, when we are hitting a method like get or post, for example in case of post, event argument will contain the message body that we passed under the post method. Right now the structure of the event will vary, so it will always be a JSON file, but the structure will vary based on what AWS service is actually invoking the function. So if I click on this link, so here you will see a list of all the services that can invoke our Lambda function. In case your Lambda function is, let's say, invoked by Amazon SQS, right? A new message lands in the queue in SQS and your Lambda function is invoked, then the format of your event argument will be something like this. It will be a list of or array of all the records that landed in the queue and then passed on to your Lambda function as event argument. In case it is a S3 invoked event, again you will get your event as list of all the records or all the file changes with the detail of the bucket and the object with the key that got changed in the S3 bucket. The next argument that gets passed is context. It contains all the information about the invocation. So it contains about who invoked the function at what time, and it gives you an invocation or execution ID, and also the information about the execution environment, like what's the memory size set for this particular Lambda function, what's the runtime, etc. I have also added a link here. If you can go through it if you want to understand more about context. The third argument is the callback. This is an optional argument. So handlers can be of two types: asynchronous and non-asynchronous handlers. So in case we're using a non-asynchronous handler, we need to call this callback function to send back response through the handler. But in case if we are using a asynchronous handler, we don't need to pass the callback, because asynchronous handlers follow the async await pattern. So when you're using the asynchronous handler, you just need to define the handler as async. It follows the async await pattern. In our lectures we are going to use the async handler and not the non-async handler that we use in our first Lambda function. Now most of the libraries from AWS like S3 now returns a promise, so it makes it really easy to return back a response directly after calling one of these API methods. One of the advantage of using asynchronous handler is you can designate the code as an ES module, and then you can use the await keyword at the top level of your code. So what does it mean? So here I have two examples. On the right hand side I have defined my code as a ES module, right? And to define it as a ES module, we need to import the dependencies using the import syntax. And on the left hand side, it's a common JS syntax. it does not define my handler as a ES module. So in cases when we need to, for example, fetch a credential from SSM, and we want to make sure that this credential is fetched from the SSM and set to the parameter value before we actually trigger our handler. Async handler makes it really easy. You can use the await keyword while calling your SSM client to make sure that your parameter value is set before your handler is triggered by your HTTP event. Now, if you're using a common syntax, we can't do that. So there is no guarantee that initial promise is resolved before your handler is invoked. So in cases like these, when you want to use await in the top level of your code and you want to make sure that these constraints or some other services are called and we get the data before the handler is invoked, make sure you use the ES module import syntax, which allows you to use the await keyword at the top level of your code. Now with asynchronous handlers that we used in our first Lambda function as well, we need to call the callback function back to send the response back to runtime. The important thing to note here is when we use the non-asynchronous handlers, the function execution will continue until the event loop is empty or the function times out, in which case it's going to send an error back as a response. Now to avoid this waiting of event loop being empty before your function sends back a response, we can set context.callback waits for empty loop value to false. Now by default this value is true, and if this value is true, then your function will wait till your event loop is empty. For example, in this case, if this value is true, here we are getting a list of buckets using the S3 client and then immediately calling the callback. But our function is still busy for another 5 seconds for this timeout method to complete. So even though we have the list of buckets ready here, the callback will not send the response back until the next 5 seconds are complete. By setting this value to false up there, as soon as we call the callback, the function will not wait for next 5 seconds. It will immediately send back the response. So this is something that you need to take care of while using the callback method. So that's all for this lecture. In the upcoming lectures, we will create a new project and start implementing all the learnings we have done so far.